actually. Yeah, I popped off for the resolution. It's kind of.
Do you need the Wi-Fi password? It's EV0.
I guess it's now going to not mirror, so whatever. We'll stick with it.
EV0 company.
All right, let me reset this real quick. All right, hello everybody. I'm Josh, and I'm going to even talk about a module that I authored and it's on GitHub. And if you guys are interested, check it out and use it. It deals with infinite scrolling, specifically with React. It's a React component. So first off, before I get started, how many of you use React or have used it or know anything about it? I didn't expect a lot of hands, which I think Angular seems to be the library of choice, but I'm going to do a really quick overview so that those of you who aren't that familiar kind of have some context, I guess, to go off of. This will be posted somewhere afterwards, so you can find the slides in the library later if you want to. All right, so first off, React is really just the V and MVC. It's not trying to do everything that another library like Angular might take care of for you. You should use it with other stuff, and it's very powerful. And Facebook, who produced this, is open source, but they originally wrote it, has a design pattern called Flux that pairs fairly nicely with it. So basically, it's just made up of components and child components. It's a React class that the library manages that sort of you stamp out templates of and you add decorators to. So I'll kind of get to that second. But the kind of key thing that they did that's different is they have a virtual DOM. So basically, what you're building when you're building a React application or a React component is some conceptual representation of your application, and you let React, the library, manage actually turning that into DOM nodes and changing DOM nodes and deleting them and adding new ones and stuff like that. And that actually simplifies things a little bit because it allows you to think about every render cycle as sort of a single snapshot of what your application state is and exactly what you want your app to look like. And so that would be very inefficient if you're actually destroying the DOM and rebuilding it every single time, which you don't do. But you can write your code in a way that allows you to do that. So they give you some lifecycle hooks specific to components that allow you to do things. So obviously, you need to be able to manage behaviors, animations, that kind of stuff. So when you're creating a component, you can provide functions that get called before the component mounts, if it's about to update, if it already updated, and if it's receiving new properties, which I'll touch on briefly what those are. The other thing is it doesn't have a special templating language. There's JSX, which I'll talk about in a sec, but it's just semantic sugar. It gets transpiled into regular JavaScript. It doesn't have like double curly braces for string interpolation, even though it might look like it. And if you do looping, for instance, in your template, you literally are writing JavaScript code to produce loops. So you might map over an array and return back multiple components, but it's still just JavaScript. So JSX looks like XML. I kind of hated it at first when I read about it, but it's actually really nice to use if you're going to use React. The top section here kind of shows you a div with a name and a p tag underneath it. That gets compiled down or transpiled into these calls to React.createElement. So React's still, doing its thing. You just get to write more semantically clear descriptions of what you want React to do. And you're not limited to just the sort of DOM elements. When you make your own components, you also reference them in these XML-like tags as well. All right, state management. So since components are nested and every sort of loop through your application, every loop through the event cycle, your browsers kind of try to keep things in sync, you are going to create a giant tree of components within components, and you want to have application state passed in via properties. That gives you, the author of your application, control over what the correct truth is, so to speak, for your component. There is internal component state, like for instance, if you have a form field, the text input, like the kind of current value that's in there, or if you're focused in it or not, that's internal component state. That's not really state that your application is necessarily trying to manage itself. And so you will you'll keep track of internal component state on an object called this.state. This references the component itself, the React component. Whereas you might pass in a style object via properties that defines how you want that particular component to be styled. So anyway. And then communication up the component tree, just quick on this, because children can sort of receive stuff from their parents. The way that goes in reverse is a parent provides a callback effectively for an event or other kind of handler. All right, so with that very, very brief overview of React, what am I trying to do with this here? So infinite scrolling is actually two problems that you're trying to solve. Large lists, so having 1 million DOM nodes in a browser is kind of horrible, makes performance pretty poor. And incremental data loading. You don't necessarily need to load everything. A Twitter feed doesn't load all Twitter's feeds forever back into history. You only get, I don't know, 100 or a few. And if you scroll far enough, the application realizes you probably want some more, and it goes and fetches some more, and it updates the list to provide that. So React Everscroll is trying to kind of solve both of those problems. Why is it unique, or why did we write it? Why did I write it? Row heights are an issue. We wanted to be able to have an arbitrary row height for any given element that's in our list, and the current components that were out there already didn't support that. They assumed a fixed height. And be able to render in reverse order. So, Twitter's top down, but if you're using iMessage, the messages kind of go bottom up. And so being able to have the reverse order was important, and so we figured we'd write something that did that for us. If you want to install it, use npm. And if you want to use it in your application, you just require it like any other node module. This is not a node-specific thing. Using Webpack, you could use Browserify, other kind of bundlers. You kind of don't need to, but you probably want to because of JSX. You don't actually want to manually take your JSX tags and convert them into React component calls. So use some kind of tool to help handle that for you. And so we are instantiating it here. I'm kind of like skipping over a lot here, but I'm saying here's a React Everscroll, or here's an Everscroll component, and here are the properties that I want to provide to it. I'm going to give it a row index. That's just a pointer to all the data. So the IDs for messages, for instance, an array of IDs. The render count, how many items you want to actually render at a given time. So if you might have an unknown, possibly millions of items, but you only actually want 100 to be physically in the DOM, you'd use that. Reverses the order. On-end reach allows you to provide a handler to the component saying, hey, when you get to the end and we want to load some more stuff, call this function. Render row handler is the function that actually decides what your rows look like. The component doesn't care what individual rows are, so you define that and you pass the function and that will return more React components that draw it. And so I kind of have a trivial case right up here for render row returning a div. Back cap and front cap just allow you to take a component and stick it on the front and the back of the list. You might need a spacer, you might need a little spinner, whatever. Okay, so what's going on under the hood? So obviously we're only trying to render a subset of information. So in the render method of this component, all React components have a render method. I'm saying, here's we're slicing our row index based off of some start and end range, and we're going to map over it. And this is what I was talking about. There's no special templating language. I'm just literally returning a div for every entry in this sliced row array, and it's calling render row. So what is the component managing? It's managing a list of IDs or whatever you want, really. It's managing a list offset, so where are we going to start rendering? And there's a render count that goes with that. And then it manages a cursor, and the cursor is basically a pointer to the element that's right in the middle of the screen or container. And it uses that to decide whether or not it needs to tweak these values. So So there's, well, I'll get into the actual how it behaves later, but that's the code. So when this component is being instantiated, internally there's an on-scroll event that we're kind of attaching to this sort of container that holds all these messages. And it's going to delegate to a HandleScroll method that is also defined in this component. And so basically every time you're scrolling in the browser, it's constantly hitting this HandleScroll method, and the HandleScroll method decides whether anything needs to change. So when I talked earlier about everything's, I don't know if I said it, but everything's synchronous. There's, you know, it handles asynchronicity, but when you start to render your application, there's, you know, it happens all at once without a break in the event loop, and so everything's deterministic. And so we've had a scroll event happen. Now HandleScroll is going to check where things are on the screen and decide whether or not we need to adjust values, and then at the end it calls set state, which kind of triggers the re-rendering, and that's kind of how this kind of application loops over and over and over again. So we may have moved the screen up, and we need to actually take rows off the top and move them on the bottom. So that might mean we have to move our offset, you know, back in line or forward if you go in the other direction. Okay, so dealing with DOM. So if you've read anything about React, they try very hard to kind of imply that you shouldn't have to deal with the actual DOM elements. They want to extract it away from you. If you start tweaking them manually, you can kind of get in the library's way, and it's also probably more effort than it's worth. But you have to sometimes, and this is a perfect example of where you have to, because if you didn't, the list would jump around all over the place because we're trying to pretend that we have 1,000 rows, but we only have 100 rows. So, so how do you get a sort of a handle on DOM nodes? It's pretty simple. This is some component, has a ref called myRefName. Now within the parent component's context, it can reference this.refs.myRefName.getDOM node. And that'll give you an actual DOM, you know, the browser DOM element. You can call DOM APIs on it, and you can actually manipulate it and change its height, you know, where it's positioned, that kind of stuff. So what do we want to do? We want to keep the scroll height in sync, and so we use those hooks that I was talking about in the beginning. Component will update and component did update to kind of do our own sort of internal diff, or not internal, but outside of the library. And so in component will update, we take a look at the DOM node that contains the list, and we look at its offset top and its scroll top and do some math, and we set up a we look at the amount of offset we want our anchored element to maintain. Now if it re-renders and we move a bunch of items off the top of the list, obviously things are going to jump around. So in component did update, we get a chance to manipulate that. And so we take that target cursor offset and we adjust the cursor's new offset so that it kind of stays in sync. And so you can get away with that because we're doing this all before the browser repaints. So it's reflowing, obviously, so that it can figure out heights and offsets and fun stuff like that. But it doesn't get a chance to actually draw the screen again, so you end up avoiding any kind of jitter or jumpiness because those two lifecycle calls are close enough together in the order of execution of the code. It does bring up a good point. I don't actually have a good answer for this, but we have a strange situation where we have a component state, that's the list offset. We have props, that's data that's provided by the caller that tells us about the number of rows and stuff like that. But we also have transient state, so we need to keep track of stuff that really only applies when you go from one update to another update. And so the probably non-optimal solution is really just to use private members on this component, and nothing prevents anybody from doing stuff to them. It's not truly private. We don't have the same kind of luxuries that other languages have for that. But basically, it's a dumping ground for tracking offsets, and then you clear them out or maintain them or update them. But they're not meant to be used outside of the will update, did update kind of cycle. But you probably shouldn't put that stuff on the actual component state, because if you do that, then you're going to trigger re-renders every time you call set state. It's going to try to, you might get into an infinite rendering loop. So, all right, how do we find the cursor? I'm using Immutable JS as another library from Facebook. It's a functional collections type library. So I know we had to talk a few months ago about functional programming and all the composability, but it gives you that. There's other reasons to use Immutable data in React, which I'm not really actually taking advantage of here, but you'll see a lot about that if you look into it. But effectively what I'm doing is I'm looping over a range of nodes that are actually on screen, meaning in the DOM. They might be above or below the container's boundaries and hidden, but and I'm checking whether or not that component, that row, is clipping the midline of the container. Oh, sorry, I'm getting in the way. And so once I find the item that clips the middle line, we take that that reference and we store that on state, and that helps us decide later in the HandleScroll function whether or not we have too many rows above it or too many rows below it. All right, so the infinite loading part, the actual incremental data loading, this is actually fairly trivial. It's not nearly as hard a problem as the maintaining a small subset of rendered nodes. We call on end reach when our list offset kind of gets as far along as it can based off the size of the data array we have. And we call whatever function you pass in. So presumably you'll go fetch more data. And if you update the list index that's containing the pointers to all these components, maybe say add another 100 or another 1,000 values, component will receive props will get called because we've now received some new information, and we get a chance to analyze it and decide what to do with that. So in this case, we're going to try to determine whether or not it's your appending stuff or pre-pending stuff, and figure out how to reset our list offsets to just keep everything in sync, and the component takes care of all that. And what could be improved? So right now it's very dependent on build tools. There's ES6 features in here that won't work natively in the browser. It has JSX actually in the source code, so unless I were to pre-build it or pre-compile it to ES5, it's not really kind of usable in vanilla. You can't just like load it up and use it without kind of investing in the tool chain. There's no reason why you can't do this with arbitrary items and not just rows. It should work more or less the same. It would take a little bit of tweaking, but the problem really isn't any different whether you have 5 items per row or 1 item per row. Bottom and top spacer sizing, this is a little bit of a hack. Right now it's basically estimating the spacer that makes the scroll handle look like it's really tiny or really big based off how big your implied list is. I didn't really talk about doing that here, but if you have a large variability in the heights of your rows, that can get a little jumpy. And HandleScroll is throttled. It drops frames every once in a while, but it pretty consistently hits 60. So performance is pretty good, but I probably could be improved more. And that is the slides, but I wanted to show you guys what it looks like. So, oh, that's not that bad. Okay. The resolution's tiny. So this is a list of letters, and then when I get to the bottom here, it's going to use, it has an arbitrary delay, but it's producing gibberish. And so every time we get to the end of the list, it's calling on end reach, and in this fake application, it's using dim sum to generate a bunch of fake messages, and so you can just keep doing this forever. And if we scroll back up, we get back to the top. So I don't know. That's 26 letters plus maybe I don't know. Maybe I've done another 10 or 20 messages here. So there's actually only 7 nodes on screen at any given time right now, and so we can see that. We look over here. Oh, well, I need to make this, the resolutions making it a little difficult, but I need, oh, yeah, I can close. Do that. There we go, cool. All right, so there's 1, 2, 3, 4, 5, 6, 7. And as we scroll, you'll see it's it's updating stuff, but there really isn't ever more than 7 divs in that box there. And this is kind of extreme. You'd actually want like 100 or 200 because there's no. I mean, it's not hard for the DOM to handle that number. And if we were to zoom out, oops, we can get ourselves into trouble because we can get in a situation like this. So you're expected to provide enough runway so that you don't kind of get in this situation. And there actually, it could be improved another way to make it a variable amount of rows that are rendered just so it knows that it clears the space. But anyhow, that's not done yet. So, and I was going to see if I could do one last thing. So this is my sample application where you can see I have my index. I don't know if I can. No, that's probably not any better. But here's my letters up here, and yeah. What's up? Sorry. All right, and so I have my render row function that's doing something silly there. If I change it so that I have it so that the cursor is being passed into the render row function. That's actually not in the real library, but I just wanted to simulate what that would look like. And I have it styled slightly differently. And you can see I'm down here in the render call to sort of this list view is the component that I'm rendering here, which contains Everscroll. I'm passing in this index somewhere, row index, clone this.state index. Yeah. Anyhow, so now I've modified the render function. I'm going to got my stuff mixed up. I want to rebuild it. So I'm using Webpack. I think I mentioned that before to compile a bundle, basically. And if I reload this, okay, so now you see the gray box. It's just styling the cursor item ever so slightly differently than the rest. So as I was scrolling, that HandleScroll function is being called. It's analyzing the set of nodes. It's figuring out which one's in the middle. And in this case, now it's actually styling it to reflect a different color. So, any questions? Sure.
So I'm not familiar with React, and some of this might have more to do with React than your Everscroll. But I was just kind of curious because there's a big problem on mobile devices on how to implement scrolling, especially when it's in combination with either header or footer elements. So I'm wondering whether what you have described here is primarily a desktop type of a layout, or will it work on mobile devices with as many different screens? So, for instance, if you're on a mobile device, can a media device call be made to determine dimensions of the screen, which then determines the number of elements? So you have a fixed number of 7 elements here. Can that be a variable number?
Absolutely. That's just a property on my component here. So you make that a variable. You can change it all you want. It will do any number that you would like.
Okay.
I made it low on purpose just to kind of.
So if you're also on a layout where there's a header and a footer, do you all? Okay, so generally, how are you? Is a scrolling chain like what you described, what you have here, generally implemented as its own chain, or does it implement as the full screen with the header and footer?
You can do it any way you want. It doesn't have to be full screen like this. It's not looking at the actual browser window size. It's looking at really the container element that contains the messages. So you can make this a small part on a bigger site. You can make it take up the entire page. It's really kind of however you choose to use it. But no real consideration was made in the React component to support that. That's just kind of how it kind of falls out.
But how are the headers and footers generally written using React? Okay, and this might be outside of what